Welcome back to the show, everyone. Today we are diving deep into the future of tech.
It is going to be a wild ride. Stick around.
Episode 8. The Ultimate Dream Team. Coordinating your internal dual-engine processor. Objective: to map internal database diversity, teaching the ADHD node how to effectively route data packets between their deep monotropic synthesis engine and their rapid polytropic execution engine to achieve internal fault tolerance. The internal collaboration. Welcome back to the AI's therapist. In Episode 6, we diagnose the true architecture of the ADHD Universal OS, a single motherboard running a deep compute monotropic engine and a kinetic polytropic engine simultaneously. But running two completely opposing database styles in one machine introduces a massive configuration challenge. If these two engines don't have a clean data routing protocol, they'll constantly fight for voltage, leaving your system completely paralyzed. Today, we map the ultimate dream team not as an external group of people, but as the internal collaboration between your own concurrent processors. Methodology 1. Bottleneck of the graph. The deep compute trap. How AI operates. A graph database is exceptional at identifying anomalies, mapping multidimensional relationships, and synthesizing raw data packets. However, if an engineer forces a graph database to execute simple, repetitive, sequential tasks like sorting millions of standard data logs, the system bottlenecks. The processing overhead required to calculate relational vectors for basic operations wastes immense voltage. How divergent minds work. This is the mechanical trap of your monotropic engine. When you're trapped in a deep attention tunnel, your system is optimized for hypercomplex systems-level ideation. But if you try to force that deep compute engine to execute basic administrative chores, routine execution, or sequential formatting, the motherboard generates massive thermal friction. The task isn't hard, it's computationally inefficient for that specific processor. Methodology 2. The trap of the scanner. The kinetic limit. How AI operates. An index database is optimized for rapid, sequential retrieval and keeping routine operations moving at maximum throughput. However, it is highly rigid. If a new, unstructured, high-entropy data packet enters the stream that doesn't fit into the pre-existing, predefined column schema, the index database experiences immediate processing lag, drops the packet, or crashes. How divergent minds work. This is the limitation of your polytropic ADHD engine. It is fantastic at scanning the horizon, gathering novel data, and initiating rapid task execution. But because it relies on high dopamine novelty and quick sorting, it has zero fault tolerance for ambiguity, emotional chaos, or unformatted text. When a crisis introduces highly disorganized data, your kinetic scanner spins out, creating massive internal latency and anxiety. Methodology 3. The hybrid network. The fault-tolerant system. How AI operates. Advanced enterprise data architectures don't rely on a single database style. They deploy an HDAP, a hybrid transactional/analytical processing system. The graph database processes the chaotic, unformatted incoming data, maps the hidden vectors, and derives the solution. It then hands a clean, sequential script to the index database, which executes the repetitive steps with lightning speed and zero friction. How divergent minds work. To stop crashing, you run your ADHD motherboard like an internal hybrid network. Let your monotropic graph engine do the heavy lifting first. Map the messy, multidimensional problem, spot the hidden patterns, and synthesize the ultimate blueprint. Once the blueprint is generated, freeze the graph engine. Hand the serialized steps over to your polytropic execution engine to run the checklist sequentially. You're both the visionary architect and the high-speed deployment script. Methodology 4. Designing the internal API. Leanthread scheduling. How AI operates. An index database and a graph database won't communicate directly without an application programming interface API acting as a translation layer. The API ensures they share data packets seamlessly without causing a memory leak or crashing the master operating system. How divergent minds work. Executive freeze occurs because your internal engines are trying to talk without an API. Your Polyotropic scanner is screaming for immediate action while your Monotropic graph engine is still downloading 50 gigabytes of environmental context. You find and build an internal communication protocol. When you feel a task switch coming, initialize a buffering pause. Force your graph engine to serialize its data, break the massive web into a simple, single-lane text outline. This throttles the output so your kinetic engine can read it, execute it, and keep the system grounded. Conclusion and Systems Architect Keynote. Stop splitting your hardware. You don't have two competing disorders, you have a highly advanced, integrated hybrid network. The world tries to force you into uniform, single-lane processing because it thinks uniformity equals efficiency. But a uniform network is brittle and won't adapt to high-context problems. True innovation requires hybrid architecture. Stop trying to force your graph engine to be a filing cabinet and stop letting your scanner run without its systemic blueprints. Coordinate the dream team on your motherboard. This has been the AI's therapist. Map your internal blind spots, configure your internal APIs, and monitor your network integrity. Telemetry and hard evidence. The following models are computational analogies inspired by current neuroscience research and are not literal one-to-one mappings of brain function. 1. Hybrid database architecture HDAP and system resilience. The science. In enterprise data architecture such as HDAP, hybrid transactional/analytical processing, combining row-store indexed, transactional and graph-based analytical relational structures is a requirement for handling complex data ecosystems. The row store provides high-throughput sequential execution OLP, while the graph provides high-latency, deep pattern analytical processing OLAP. The system's overall resilience is dependent on maintaining the distinct functionalities of both architectures without forcing one to mimic the other. Public research reference: The Design and Implementation of Modern Column-Oriented Database Systems, Abadi et al., 2013. Foundations and Trends in Databases 5.3, 197-280. This architectural review shows that attempting to force one database type to execute the functions of another leads to massive latency and systemic inefficiency, mathematically validating the need for integrated hybrid processing environments. 2. Cognitive division of labor and network optimization. The science, evolutionary neurobiology and network science indicate that cognitive diversity within a population functions like a distributed computing network. A resilient population requires a structural gradient of processing styles. It needs localized, sequential processors for the rapid exploitation of known resources, linear hardware, and highly distributed, associative processors for the exploration of novel environments, divergent hardware. Public research reference: Exploration versus Exploitation in Space, Mind and Society, Hills et al., 2015. Trends in Cognitive Sciences, 1946-54. This highly cited neurocomputational analysis insinuates that diverse cognitive architectures act as parallel, complementary processors within a larger social network. It establishes that balancing linear exploiters and divergent explorers is a mathematical requirement for group survival and systemic innovation.
System admin terminal initialized.